Hey, and welcome back to another video on the channel. Today I'm going to be showing how to set up a simple rig in Blender using an add-on and then importing that vehicle into Unreal Engine and then setting it up, as well as showing anything that you're gonna need while setting up the vehicle to try and get it as close as possible to its real world counterpart as you possibly can. So with that being said, let's get into this. Firstly, I just want to say that the model that I'm using in this video is not mine. I have no rights to this. I will leave a link in the description to the Sketchfab artist who actually created this. If you want to go check it out, the link will be down there. So firstly, you want to make sure that when your model in Blender only has 5 meshes. So you need the wheel separated and then the body as one whole, right? When setting up the vehicle, as you can see by the add-on, it's going to ask you for 5 things. It's going to ask you for the vehicle base, the front right wheel, the right rear wheel, the front left wheel, and then the right left wheel. And then you're just gonna have to pick each one of them. This will translate when you edit into Unreal Engine as the bones, as well as the root. The vehicle base will be the root. So that, and then leave everything as is. Set unit scale and then upscale it. So what happens is when you set unit scale, it's gonna downscale the model and then you upscale it to get it back to its regular size. This just translates it from Blender's default metrics to Unreal's default metrics. And then after that, you just click rig vehicle and then you'll have the 5 bones edit. And then the vehicle is set up, pretty much set up at this point. You can just take it from here and then put it in Unreal Engine at this point. Just go out into object mode, select everything in the scene. Make sure that your vehicle and the bones are the only things in the scene. It just makes exporting a lot easier. You're gonna export the vehicle over to export FBX. Okay, I already have a file because I did this before while I was practicing for the video, but just save everyone, selected objects only. That means anything you selected. Then for the forward, you want to make sure it's X forward, and then for the up, you want to make sure it's Z up, because that's how Unreal understands its axes. Then you want to go over to geometry and then select face, and then you can close the geometry and then go down to armature, unclick the add leaf bones, because that's gonna cause problems when you import it, and then uncheck big animations, because we want to set it up using the chaos vehicle system so that we can control the vehicle ourselves. Okay, now over to Unreal Engine. We're not gonna try and reinvent the wheel because Unreal already has a template for us to use that already has the controller set up, the game mode set up, and everything that we can just use to then set up our own vehicle. So I'm gonna use that. Okay, here's a couple of things you're gonna need for the vehicle setup in Unreal Engine. You're gonna need the vehicle's max torque. You're gonna need the wheelbase, the length, the width, the height, the vehicle's turning circle, the curb weight, the max torque range, the shift point, the max RPM for the vehicle, what type of vehicle it is, front wheel drive, rear wheel drive, all-wheel drive, the amount of transmissions the vehicle has, the drag coefficient. If you can find the downforce coefficient, that's a bonus. You're going to need the gear ratios for every gear the car has. That would be, I don't know how many gears the car might have, but in this case you only have 2, and then the reverse, the final drive, and then the turning angle of the vehicle. All of this is going to need to be Unreal. Not all of it, some of it is going to be used for the equation over here to get the turning circle, which is A10. You need the vehicle wheelbase, the length of the vehicle, and then the width of the vehicle, and then you're going to get this out as a radian answer, and then you take the radian answer and you convert it into degrees, which is then what you're going to add into Unreal. So now in Unreal Engine, we're going to go over to the vehicle, and then you're going to add a new folder. You're going to name this whatever vehicle you have. For me, it's the Taycan. You're going to open up that folder. You're going to create another folder and you're going to name this one materials, because if you import the materials, you're going to put them somewhere. But if you're not going to import any materials, then you still going to need this folder just when you create materials for the vehicle, and then just import the FBX specs file that was saved, and you can pretty much just leave all the settings like that and then just import all. Okay, now everything has been imported. I'm just gonna move the materials over into the folder that I created just to make everything look a little bit nicer. If the import has been successful, you will have three of these. You will have the skeletal mesh, the physics asset, and then the skeleton itself. So what you're going to do is you're going to open up the physics asset real quick. We need to change some of the settings in there as well as some of the collisions. Okay, with the physics asset open, just going to drag it up to the top and dock it there. Select the capsule for the body and then go over to the primitive type, set it to box. This just makes calculating easier. Deselect the auto orient to bone, regenerate bodies, and then select the capsules that's around each wheel of the vehicle as well. Check the auto orient to box, change the physics type to kinematic, and then change the primitive type to sphere, and then just regenerate those again. And then you can save, head over back to the vehicle example map. We're gonna right click, drag in the skeletal. We're gonna need that for something in a little bit. Right click. First head over to your plugins. Make sure that you have the Chaos Vehicles plugin enabled. If you didn't and you check it, it's gonna ask you to restart Unreal, and you just restart and come back. And then we're gonna right click, go to blueprint class, go to all classes, and then search for the wheeled vehicle pawn. If you have the plugin enabled, you will find this. If not, it won't be there. And then just select that. Rename this. I'm going to rename mine to BP Taycan. And then we're going to open it. You're not going to see anything in the viewport. Click on the mesh, head down to the skeletal mesh asset, and then select the vehicle that you just imported. Close out the materials tab, and then head over to the vehicle movement component. We're going to set up the wheels. Under wheel setup, just going to add 4 of these. Open up all of them. Head over by wheel class. You're going to add a new wheel class, a new blueprint for the wheel class. Select the folder where you save your vehicle. You can rename this. I'm going to rename mine to Taycan front wheels. Just to differentiate between the front and the rear wheels. It's gonna between the blueprint for the front and rear wheels. It's gonna drive each one respectively. Over by the Excel type, set this to front because it's for the front wheels. I'm not gonna play with any of the settings right now. Just gonna do the wheel radius and wheel width. That's why you have to drag in the skeletal. Over in the viewport, set it to top view. Select vehicle or find your vehicle. Deselect it. And then middle mouse button click, deselect the magnet, middle mouse button click, and then just drag and then get your metrics. This one is 30, it's got a width of 30, and then the diameter of the vehicle is 79. And I'm gonna put that back in perspective. Head over to the blueprint. The wheel radius is the diameter divided by 2. And then wheel width is 30, as we just got. And then we're gonna check affected by brake and then affected by engine. And then we're gonna enable affected by steering. And then we're gonna compile and save. And then we're gonna close this one. And then we're gonna head over to the vehicle example map. Just click on that and then just Control D to duplicate it, and then rename this one to rear wheels. And then open it, then change the Excel type from front to rear, and then head down to affected by steering and then uncheck that, and then compile and save. You can close that up. Then as you can see by the wheel setup, the first one has already been selected because we created, and then by the second one, index 0 and 1 is the front wheels, and then index 2 and 3 are the rear wheels. So just make sure that's orderly. And then the bone name are going to be the bone names by the physics asset. Make sure the bones are spelled exactly the same. If there's it's case sensitive, so you spell exactly the same. In my case, it's very simple. It's just two letters, two capital letters for each one. You set it up the same way as it is there, from top to bottom, exactly the same. Nothing changes. And then with that, we're done with the wheel setup, compile and save. We can close the wheel setup. We're gonna go down to the engine setup, under the mechanical setup. We're gonna open the drop down. We're gonna play with the torque curve, create external torque curve. Yet again, where the vehicle is saved, you can just rename this. I'm gonna rename it into Taycan torque curve, and then we're gonna open that. And then for the time being, I'm not gonna recreate the car's actual torque curve. I'm just gonna put in place some keys to represent where I'm gonna make the change. So for now, I'm just gonna put in 4 of these. In the link, one of the links down in the description is to a website that I use when I want to find information on vehicles. It will show you all the things I listed before that you're going to need for the vehicle setup, as well as the vehicle's torque curve, if you want to recreate the vehicle to pretty much as close to its real world counterpart as possible. These are information that you're going to need. And then with that done, just going to compile and save, head back to the vehicle blueprint, compile that. As you can see, the torque curve has been updated. And then we're going to play around with information here. This is why you need the information that you need, because you need the vehicle's max torque, the vehicle's max RPMs, the idle speed you can play around with however you feel like. The engine brake effect, you can also play around with it, as well as most of these other settings. And then we're going to set up the differential. This is where you need your vehicle's drive type: front wheel drive, rear wheel drive, all wheel drive. Then the front to rear split, all the way left is front wheel drive only, all the way to the right is rear wheel drive only, so that determines how the power is going to be split. And then you set up your final drive. By the forward gears, this is going to be the gears we needed, and then by the reverse gears, these are the ones we needed. And just add your values. And then by the change RPM, this is the change up RPM if you need it. And then the change down, you can pretty much set this. Don't put the two too close to each other, because then when your car changes down, it also might change up. You're just going to interfere with power delivery. And then the gear change time, we're going to set that pretty low. And then the efficiency transforms how much of the max torque is actually being delivered to the wheels. So in this case, it's 4.9%. We also want to change the vehicle's mass, and then the vehicle width, the vehicle height, the drag coefficient. This is where you need the downforce. If you can find this, then it's a bonus. So compile and save. Then we're going to head back over to the curve, and now I'm going to recreate the curve as it is to the car's actual torque curve. On the top curve, it's time versus scale, so it's value over time. So 1 represents full torque, and it goes down, so it's like percentages. So 1 is 100%, and you scale it down to point, all these things. And then on the left, you determine the RPM. So that will be so on the left hand side, it will be the RPMs, and on the right will be the percentage of power at that RPM that needs to be delivered. Then we're going to head over to the mesh. We're going to look for a spring arm. We're going to add that into the vehicle and select the spring arm, and then add a camera. You can't add a camera without a spring arm. So the spring arm comes first, then you attach the camera to the spring arm, and then the spring arm is attached to the vehicle mesh. Move the spring arm's Z location to 75 just to lift it up. the spring arm length to 650, make it a little bit longer, and then the socket offset determines where the camera is going to be offset from the horizontal line of the spring arm. And we're going to go up again, we're going to delete our skeleton we added earlier, and then we're going to add the vehicle blueprint that we just set up. We're going to head back over to the vehicle, and then you're going to, under physics, just click on simulate physics, compile and save, head over to the event graph. By the event tick, we're going to drag in the vehicle movement component. We're going to drag off from the vehicle movement component and then search for set throttle input. We're going to connect the execution pins and then set the throttle input to 1. Then compile and save. Head over to the vehicle example map, save. Then under the select the vehicle, and then under auto possess player, select player 0, just so the controller can take effect, and if you press play, the vehicle will then drive forward. Obviously you can control the vehicle, you can set up the functions for the jet. We're gonna do that now. Deselect from the auto, from the event tick, and then right click and search for enhanced input throttle. Connect the trigger and the complete to the execution pins, and then the action value to the thrust. And then right click again, search for enhanced. You want to go up, look for you want it to be like events. You want to duplicate the vehicle input component, and then you want to search for set brake input. Then we're going to connect the trigger, the action value, and then we're going to duplicate the set brake input. Then we're going to connect the completed, and then connect the vehicle input so that when you release it, the braking power goes to 0 and the car just coasts. Then we're going to search for the handbrake input, duplicate the vehicle movement component again, search for set handbrake input. We're going to connect the trigger. We're going to do the same we do with the brake, copy and paste it, and then check on new handbrake, and then second one, connect the completed, but don't check the new handbrake. Then we're going to search for the steering input. We're going to copy the vehicle movement component, drag off, search for set steering input, connect the triggered and the completed, and then connect the action value, and that's it. With that done, we can now control the vehicle. Hit play, we can test it out, and the vehicle should move. Now as you can see, the vehicle is a little bit wonky and it's not moving. It looks pretty stationary, the wheels aren't doing anything. We'll change that in a minute. Search for the enhanced input look around function, and then drag in the control arm from the control arm, drag off, and then search for add local rotation, and then connect the triggered execution pin down there. Search for the split strut, connect the action value to the delta rotation Z, compile and save. Go back to the play, and then we should be able to look around after using the mouse. Head over to the BP Taycan blueprint, and then in the viewport, select the vehicle movement component, and we're going to go down to the enable center of mass override. And then with this, you can pretty much choose yourself where you want your vehicle center of mass to be. And then from the vehicle folder, select skeleton, right click, and then go to create new. We're going to select an animation, and then we're going to open up the animation blueprint we just created. First of all, we're going to go to the class settings. We're going to change this from animation instance to vehicle animation instance, because without that there's going to be a node that you won't have access to. Then right click and then search for mass space fast pose, pull it over to the side, right click and search for the wheel controller, connect the two up, and from the wheel controller connect to the output pose, and then everything is set up. Compile and save. Everything is good now. You can close the animation blueprint, head over to the vehicle blueprint. Under the viewport, make sure the mesh is selected, and then under animation class, select the animation class we just created, and that the vehicle should now the rotate, the wheel should rotate as well as spin, and the vehicle should then, the suspension should then work as well with all that setup now. So with this, the vehicle is pretty much set up. You can pretty much just play around with the settings now as you see fit. Try and get the vehicle to drive how you want it to drive. That will be, and then over here by the max steering, let's see, you want to put in the turning circle, the turning angle.